the best replacement for a human finger, pork. And where do you get pork in a all-inclusive? Well, you wait for breakfast buffet and steal a sausage, right? When you turn on the machine, it would start everything at 100%, and then when BIOS software would kick in, it would start controlling the fan speed. You would have several seconds of jet taken off, and then you would know when someone's making a build.
Hello everyone, and welcome to Wookash Podcast. This time I'm joined by Tomas, who is a programmer and a game developer. We talk about his past experiences while working at Unity and complex build systems for games. Join us.
Many things happened at Unity. Xbox 360 happened, a lot of difficulties getting mono scripting to run there, getting to perform, but then all of the work we put into it gave us the Microsoft contract, and money was useful for a small company at the time. And that also meant we could do Xbox One and other Microsoft platforms, for better or for worse, if you remember Windows Phone.
Oh yeah, I had one.
Yeah. I also had one, and I think the user experience was really good. Unfortunately, it never took off. Yeah, well, after that, I started working on 2D because Unity had no 2D features, so we were researching on how to do it the Unity way, let's say. You might think that having just sprites or something would be simple, and maybe if you do your own tech, it is. But if you have an established engine, you want to do it the Unity way, let's say, it's becomes challenging. And at the time, one of the co-founders was very strict about keeping Unity simple. And so essentially, if you had a checkbox, you need to talk about it. But that complicates things. So the idea was to have Unity be streamlined and simple to use, and everything does what you expect automatically.
Okay.
Not so much nowadays.
Yeah, I was I was tempted to say that it's quite a different Unity now.
Mm-hmm.
Okay. Is it then when you work on the build system?
Oh, the build system was essentially something that happened in the background of most of my work everywhere.
Okay.
For example, for Xbox 360, we wanted to do tests on it, and Unity had a graphics test suite at the time. And so we needed to have the Xbox plugged into the build farm, which was a fancy word of calling a few computers in a storage room. And I think this whole fascination with automation started then when we started hooking that up, making it work for Xbox and PlayStation, and then eventually phones. And it led to, never growing suite of tests.
Okay. Maybe we can zoom in a little bit on this. So, usually when you're developing software, you develop for a specific platform. And if it is a cross-platform, you usually want to have, in a way, like maintainable number of platforms. And when you're Unity, you have this issue of trying to address virtually every platform possible, right? Everything that has a screen ideally should be able to run. Your games should be able to run there. So how was this done to have the ability to test whether given Unity product will be able to run on a given platform? Like how do the build farms look like? And now, by the way, we're talking about the build farms for Unity or making sure that Unity applications can run on the platforms.
So I think we can take a look at the work that you need to do first before you even consider build farms. So first of all, how do you build Unity itself? And at the time, Unity had separate editors if you wanted to make a project for the iPhone or for the Xbox, for example. even the editors themselves had to be different, because when I don't even remember now, it was so long ago, maybe they were even on different repositories, completely separated on Mercurial at the time. Wow,
Okay.
so long ago. So normally, nowadays, you'd probably build it in one repository, put some conditional compilation commands in there, and be done with it. At the time, there weren't a lot of methods, or like not enough infrastructure done yet in Unity to support this kind of development, especially if you consider Unity to be this kind of combination of multiple languages in one. The engine itself is written in C. Then it uses Mono to interface with C#. Part of the engine is written in C#, mostly the editor interface. And then at the time, they also had JavaScript and Boo language support, which came in with their own toolchains. In addition, if you wanted to support another platform like Xbox at the time was quite secret, just like PlayStation. So you don't want to put in tooling from something that has contractual NDAs into an editor that you put on your website to sell, So there were a lot of these complications. And at the time, Unity didn't even have this concept of add-on installers like you would get now. You install Unity and then you can select Windows, Android, whatever. So we had to invent those first, and make those installers essentially patch your editor to support the platform. And that's how, let's say, if you were a certified console developer, that's how you would get tooling that wasn't meant for everyone deployed into your installation.
Okay.
So that was essentially the first part of getting Unity working with many platforms. Now, when it came to testing, okay, that's step 2. The test suite that was written, it was essentially testing the graphics test suite, at least. It was testing rendering capabilities. And so it had to support, of course, various hardware. On PC, it wasn't a big of a problem. But for example, on Xbox, some features wouldn't even work. So you needed to take that into account, basically. Design exceptions, or maybe you would find on Android specifically driver bugs on one device, not on another. So you needed to start adding support for that and thinking about it. And that's where build farms came in. At first, before you even start considering a build farm, you need to have the build system. Something that could be reproducible, robust. You type in a command and you get the same result every time, like a build. Now, sorry, I don't remember what exactly was in use in 2010 when I joined, but I think it was some weird language just to define builds that. What was it? I can Google, look for it. But it was something bizarre, I remember. What it was doing is defining, the dependencies. Like if you want to build this, you also need that tool, and you need to maybe unzip that and have that compile another binary, whatever.
So it's like a CMake alternative to build, to even like configure a project. What is a project? What are the dependencies? And what to do as parts of like build steps for each of the module.
Yes, you can just say it's a CMake alternative.
Okay. So, so how do you manage this complexity if you have so many runtimes? You have like C engine, you mentioned JavaScript, Boo, and C# for the scripting layer, parts of the editor, and C#. Like, how did it work?
Oh, we wasted a lot of time to make it work, to be honest. Took a lot of
Wasted,
manpower from what I remember.
wasted,
Uh,
or like it took a
Many
lot of
people,
effort.
it took a lot of effort. Many people would contribute to the build system. Every platform essentially had someone responsible for it, and you make change to your tooling, you update the scripts.
Okay. Okay. I can imagine that it must have been a mess to have a lot of parts that you want to build and then for a lot of platforms. And most of the things probably don't look alike. Like Xbox is a different platform than phone or mobile phone in general. There's different operating systems. So how do you manage this complexity in the build? Is it just like a huge giant scripts that you start to put in like if else statements, or you're trying to derive some sort of common abstraction for all of them?
There were different use cases for, you know, just conditionals, macros, or you might want to make just a file that would have all of your platform code in it and then link that instead of the other platforms. So it depends. There sometimes would be optimizations like for iOS, Neon assembly instructions for what was it, skinning at the time that you couldn't get on other platforms. So you're absolutely right. You would have ifs in some areas. You would have conditional compilation in a lot of places. You would have source files dedicated to a certain platform. You would have with the add-on installer, you would have managed C# DLLs that would provide some sort of a plugin-like behavior for that specific platform. So there were obviously unit tests for certain things, certain small things. I don't recall a lot of so-called integration tests that would test features in a major way at the time. There was a lot of manual testing. There were game projects at the time when web plugin was still alive. Because at the time with browser plugins, you had to be absolutely backwards compatible. I would call it the Microsoft Word for games, Unity. So there were entire game projects running as part of the test suite. But I think if you expect a really fancy answer for testing, then I cannot give it to you because it was ad hoc, very ad hoc. Testing, of course, grew, and the number of tests grew significantly over the years. But back in 2010, it wasn't much. There was not a lot, let's say, because there were enthusiasts in the company who would do test-driven development, but it wasn't the main way development was done. Development
Okay.
was mostly experiment, iterate quickly, figure it out, and then maybe make a test for it.
Okay. What when you say that there was a build farm, how do you scale from having the ability to run the build on your machine to establishing a build farm and some sort of automated process to do that?
If you're asking about nowadays, there's middleware that can help you. If you have a command in your version control, so I could just, let's say, pull git and run a command and it builds, then it's quite easy to automate it. Jenkins is very popular. My favorite is TeamCity for its user interface that's understandable by everyone in the team, even the less technical people, let's say. Though pricing might, put off some people. And the way it works, you have this orchestrator and like web server where you can take a look at the builds, and you have build agents, which are usually just another other computers on the same network, and they take care of it for you basically. Steps like checking out version control, getting sources, cleaning up after the build are done for you, and what you need to provide is the build command and instructions how to collect the build artifacts. And having done that, you can, depending on what middleware you use, you can have a nice project layout in the UI, click a button, and you get to build it eventually. So this is, the high level overview. If you dig deeper, of course, there's a lot of challenges in automating certain things, and I remember some fun stories from those. One of them is, and this I think needs a bit of a background. So one of the challenges at the time was automating iPhone tests. And iPhones had a few form factors at the time, a few devices, and they would pop out this annoying system message. I don't remember what it was, but you had no way to programmatically detect it or know that it's there or respond to it. All you had is physically go to the phone and tap on it. And at some point, we had many of Apple devices in the farm, and someone would have to come up and, oh, look, this is, our build farm is red because, this phone has the message on. So that kind of negated one of the reasons you want the build farms, robustness and repeatability. And coincidentally, pretty soon we had one of the hack weeks that Unity would do periodically. And we all went to this all-inclusive hotel in Malaga, Spain. And we've been at Unity for a few years now, and I thought, like, this time let's do something with hardware, because just doing software hack weeks, it's getting old. Everyone's doing it. So we brought Arduino, sensor, servo motors, and there was, I think, 4 people in my group who were interested in that. And what we did was first a sensor that you put on your screen, and then it would tell you what's the latency from Unity doing an update and from the and to pixels changing on the screen. So you could monitor, how that changes in different laptops, for example.
Wait.
But I think...
Wait. How did it work?
So we made it so that Unity talks to Arduino and tells it when the update is done, like when your scripts is run, when you change something, like move an object. Okay. And it would then look at the sensor when the colors on your screen change, and it can tell you like the full round trip, essentially. I don't know if it's useful for anyone, but you can do it with a high-speed camera nowadays.
Yeah. Okay.
And the second project was about solving the iPhone pop-up. So the idea was that if we can physically press on the iPhone, we can fix our automation problems. So at first there were very tame attempts at figuring out how the screen works, how we can fake a human finger. And I think just putting some metal didn't work, putting a coin didn't work, but putting a coin and running some current over it kind of worked. I just don't remember why that wasn't a viable approach. And you know what worked? The best replacement for a human finger, pork. And where do you get pork in a all-inclusive? Well, you wait for breakfast buffet and steal a sausage, right? So what was done is that a sausage was attached to a servo motor, and it would touch the iPhone. It was then known as the sausage assistant.
Nice. Okay. Did it
Unfortunately,
make
never
it?
put into production.
Okay. Why?
I think the sausage would go bad very quickly.
Yeah. But you could replace sausage every one day, probably. And you could save some pop-ups. save some time.
Maybe.
Okay, nice. How big is uh how big is the build farm? At least was at the time. Was it just like an example
It's
for each
important to
platform or?
remember, but you probably would have like maybe, let's say 10 computers running builds, and because consoles such as Xbox and PlayStation, you can control them remotely over the network. You can plug in as many as you need. So maybe you have two Xboxes that any computer can talk to. For phones, it was different. I don't remember if all phones could do network like deployment over Wi-Fi. So some of them had to be physically connected to the device, to your PC. I mean, and there were a lot, all the different Apple devices, and Android needed its own shelving units basically.
What does it
The
mean?
amount of phones that Unity had in their Android test
Ah,
farm was absolutely insane. Everything you can imagine from really weird manufacturers.
anything more about the build system?
Well, there's a lot to share in terms of making your own. Lately, the automations that I was making, they would involve Unity baking light maps, and I like to use virtual machines for automation because it's very easy to copy paste them, and now you have more build agents. But with Unity baking light maps, you need a really good graphics card. Well, primarily video memory. How they get a virtual machine with a lot of video memory, a good video card? Do I put it on the cloud? But that's expensive. But I could do it. Do I put it on a machine in the office? Sure, I can do it, but the machine is, physical hardware. I need to maintain it like a physical machine, and then I cannot, let's say, copy paste it. Something that was interesting at one point is buying used enterprise hardware. Something like bargainhardware.co.uk web shop. You can get really cheap old servers, and they come in all shapes and sizes. If you look for workstation, those are typically just very custom-made, powerful desktops.
Okay.
Why I would get those is mostly because of working in financially constrained situations a lot of the time, but also because it's enterprise-grade hardware, and you could run something like VMware's ESXi. It's free hypervisor, and it's like tier 0 hypervisor. Maybe I'll just explain what's the difference in virtualization.
Yeah. Yeah.
So normally, how many people probably experience virtualization is they have something like DOSBox on Windows, and they emulate all of the commands that an old processor would do in DOS. So this is called, like, I think, tier 1, because you're virtualizing something on top of your operating system. But nowadays, modern computers are basically designed to be virtualized, and they have things called memory mapping units, and they can do memory mapping for devices like your graphics card, for example, which means that you can go level down and have, for example, Linux KVM is a good example. You can have a solution where you run Linux and you virtualize Windows as a virtual machine, but it's the hardware helps you do it. It maps out a certain area of your memory. It can map directly to resources. For example, you can say that this USB port on my computer will directly map to a virtual machine. And so you lose no performance, essentially. It's just memory mapping, which is a physical controller, should be fast.
You were doing this for your own personal project or is it work related?
It was always work related, yeah.
Okay.
For personal
Okay.
projects, I did build a gaming rig once for the living room, which was Linux with an iGPU, and then a graphics card that was passed through into a Windows virtual machine. Just an experiment, really, because Steam doesn't always like you playing virtualized games in virtual environments if it's a competitive game like Counter-Strike. You might get problems with anti-cheats.
Can you walk me through the setup again? You said Linux PC.
It's a desktop PC with an integrated GPU. That's fine for running Linux, and it has a dedicated GPU that would be directly mapped to a virtual machine that's running Windows. And
Okay.
so you can like remotely connect to Linux, and then you would feed the video output from the GPU, which is directly in the virtual machine, to your TV, for example.
Okay, nice. Nice. I didn't know such things are possible. I was in the like constrained PC desktop thing. Okay.
What's even more fun is that you can put multiple virtual machines on the same PC. And if you go online and you know this channel, Linus Tech Tips,
Yeah.
you will find a video where they took the scariest desktop you have ever seen, and they put 7 virtual machines in it. And I think they played Unreal with 7 monitors on one desktop.
Okay. Okay.
So it's crazy, but I don't think it's really practical that much. I can tell you a funny story of what happened when I bought used hardware without reading the fine print.
Okay.
I was telling about workstations that you can get that are usually designed to be quiet and sit on your desktop. And I was building a new in-house built farm, which was supposed to be just one beefy workstation capable of doing like a couple of virtual machines to make builds, because we were making a game port and we needed to constantly churn out builds and run an automated performance check, which involved a pre-recorded set of inputs that would play the entire game from start to finish.
Okay.
And would capture screenshots and do like fuzzy screenshot comparisons to ensure that the game's passable and it looks good in all of the key locations.
Okay.
And what I bought, when it arrived on a pallet and it was really heavy, I thought, something's off here. And what they brought in was a tower, but a very big tower. I was worried that this might be bad. I don't know what what about it worried me at the time until I turned it on. Imagine a plane taking off. That was the sound in the office because accidentally what I got had 4 16,000 RPM fans, jet fans that are designed to cool server farms. And you were supposed to rack it in the server room somewhere in the basement, not put it in your office.
Okay.
So that was a headache for a few days until we soldered out all of the fans and replaced them with quiet Noctua fans. It's just one lesson: don't buy server grade equipment if you don't have a server space.
Nice. Did the cooling work then? Because I would assume that the huge fans were designed to cool the equipment. So if you replace the fans, I would assume the average temperature would go up.
Well, the fans were designed in that case to blow air through the whole case, and it had passive heatsink on the CPU even. What we did is we put a fan on the CPU itself. Well, it was a dual CPU system, so we put 2 identical fans on CPUs and just kind of got power from somewhere by snapping cables.
Okay.
These enterprise grade machines usually have very bespoke cooling solutions. All these pipes funneled out inside the case. You can't even put anything else in there, but they direct airflow really, really precisely. Very fun to open up and examine.
Okay. Okay. So it wasn't overheating. It was
No, it
just
wasn't overheating. It was just standard.
okay.
It would
Okay.
drop down, but it was still noisy, And if you do a build, obviously it needs full cooling.
Oh, so you could tell by the sound when somebody was building it, a game.
Basically. It would boot up at first. I think when you turn on the machine, it would start everything at 100%, and then when BIOS software would kick in, it would start controlling the fan speed. So you would have several seconds of jet taken
Yeah.
off, and then you would know when someone's making a build before we did finish.
How many people were living with the jet engines in the
It was
office?
5. It was a small
Okay.
team just for porting.
Okay. Nice. Nice. All right. This was Unity times.
Now this was way past.
Way before.
No, it was
Way
later
after.
after Unity. Yeah.
Okay. 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 Okay.
Somehow I ended up doing many of these in-house setups for automation. Um, one of them was actually pretty cool because the company decided to invest money and bought 2 proper enterprise servers. And it's running, I think it's still running about 10 virtual machines doing builds, but the builds are huge. It's a big game, 60 gigabytes, I think.
Okay. How does the build farm and generally speaking the servers look differ from the ones that you would use for the smaller games? Like, what is the main difference? Like, everything is bigger in terms of like the CPU, disk, and stuff like that, or are there some more subtle differences as well?
Um, well, the hardware is different. It's enterprise grade, so you would have different protocols for your disks, for example. You would have ridiculous amounts of CPU cores and memory. You might have like 8 drives on the machine. Um, yeah, from just walking in the office, you probably couldn't tell really if it's a cozy workstation just beefed up to do builds.
Okay. Is it, do you, like, for the larger games, do people build them differently in order to like facilitate easier builds, or is it the other way around? Like, you don't where do you care mostly about the build time, like on the game side of things or more on the infrastructure that will be used for the building?
Um, so are you asking about how to get the build out as fast as possible?
I am wondering more about the like the on the in the idea space, right? Like, if you imagine that I'm making a Witcher 4, right, in Unreal 5 or maybe 6, if you have like maybe they have like super cool access to like the brand new stuff, right? And I'm wondering, knowing that this will be a huge game, huge amount of assets, textures, animations, models, whatever, uh, is there a place for innovation on how these are stored and packed in order to facilitate the quicker builds, or will this be built in the same way as if a basic prototype in Unreal, but the beefy infrastructure will make it run faster? Like, is it possible to optimize this on the engine level in order to facilitate the quicker builds?
Oh yes, absolutely. There's examples in the industry that how a studio can transform their workflows by just doing builds differently. And the reason why it's kind of tricky to do this with Unity is because Unity for a long time had a very strict build pipeline where they would scan your entire project, see what you're using, grab references, and build that. And for a long time, you didn't even have incremental builds, so you would have to do that every time, and the time would grow. Then I think you got incremental builds for scripting at some point. But then you also got L2CPP, which meant translating your C# into C++ and compiling that, and that step started taking a while. As well as the shader graph. It kind of brought in an explosion of shader variants, which also increased build times sometimes. If you were unlucky to change a specific shader that was used a lot, maybe you would have, a lot of extra time on your builds. So with Unity, I think they're going in the right direction, and they have asset bundles and addressables now. So you can, if you're making Witcher 4, you probably want to use those and export some assets separately, not as part of the main build process for the game. Maybe try to optimize that so it's small and iterative, and then you retrieve your assets externally. Small game probably would not do that. It's just a lot of extra work. For Unreal, I cannot really say. I haven't been using Unreal a lot, really. I only did one quick project on it to help deploy a game to the cloud. That's about it. And if you want to like holistically look at what builds really are and how you can improve turnaround time, there was a very interesting article about, I don't remember the studio name, a European studio, I believe. What they did is they would put all of their assets and all of their binaries that they produce on a central server in the office. And if you make changes to the game, you probably make changes to only a few assets at a time, right? Maybe some script files, maybe the texture. And so you would essentially, what would happen is that those changes would produce a new build, but that build wouldn't exist like 100 gigabytes of files on your disk and wouldn't be fully packed up. It would exist as a new set of changes on the build server, on a machine which has all the possible combinations of what you were doing, and your build is then like a hash code of what assets and what scripts and their versions you need to put in a build, and you play it live, and it streams you the content from the server as you play.
Can you
That
say
makes
it?
sense.
Can you say it again? I don't think I understand it. So maybe
Oh,
what would be the standard way to build? Because like we kind of skipped that part. What would be the build artifact for a game, right? And then how this artifact was different.
so let's say you're building a small game with Unity. You press build, and on PC you get an executable, and you get a folder with your data files. And that's the game you can run. You can ship it on Steam if you want to. That's it. That's your build. If you have a setup that's let's say client server, and there's a server tracking all the changes everyone does, um, like in the article. So when you think about it, if you make a build with only a few changes, you probably have 99% of your content still the same. So you don't need to rebuild it. So you can think of it as a very fancy caching solution for your assets. The question remains how you retrieve them. And what they did, I believe, is a very long collection of identifiers of what my build is, how it's constructed out of like which version of the executable I need and what assets to go with it, and if I
Ah,
simplify it.
okay.
And because they had very good LAN in the office, very fast one, not gigabit like we're used to at home. They can deliver those assets very quickly to anyone who wants to play a build.
Okay.
And
Okay, I
stream
get
them
it.
directly from the server.
Oh, that's so cool. That's so
It
cool.
is cool, yeah.
So what you need really is the way to properly identify all the assets separately and then say, okay, this build means this list of assets.
Yes.
And then it's
Yes,
like
essentially.
ship the files over and there you go. That's so cool. Okay, nice. Nice.
Of course, there's a lot of complexities with shaders in particular, because they're often dependent on code and even more often on the scenes themselves. Maybe this scene has a place where you can have this kind of shader with just this weird amount of lights or whatever, and it gives you a new shader variant. And if you support that, it's extra complexity.
Yeah, for maybe for listeners to give the context, like if you have any shader and you have any thing that you can modify it from outside, if you compile the shader, you need to compile all the alternatives, right? You need to end up with all the variants. So if you Google like a shader compilation meme, you have all sorts of memes, people waiting for shaders, especially in Unreal, to wait waiting people waiting for shaders to compile because you have this exponential explosion, right? All the alternatives, all the parameters that can be set this way or that way, or the strict numbers like integer values, like they all multiply the number of shaders that need to be compiled separately. So that's a tricky part of the build pipeline for games.
Oh yes, and we had a incident with Unity where a bug would cause a fresh recompile of shaders to go up to 8 hours on our project.
What?
So people would go on the build farm, look at the build that's been there for 6 hours and say, hey, the build's stuck. We need to restart it. No, it's still doing shaders.
Okay. This was only the basic shaders, right? That were shipped with Unity.
URP.
Okay.
There was
Okay.
a keyword explosion after one update, and then it took a bit of time for them to figure it out and fix it. But there were a few versions of Unity a couple of years ago where it was a long time to build shaders. So we
Okay.
didn't use those versions.
Okay.
Once we had this problem where people would edit scenes and would stomp on each other's work because scenes would be difficult to merge in Unity.
Yeah.
Well, actually, probably in any tool, something that you do creatively will be difficult to merge in a text interface with someone else's work. So, it's a very trivial example, but what we did, we put a little lock icon on next to the scene name, and you would click it. It would talk to a local server, say, that this guy is now locking the scene, and it essentially invented a poor man's version of perforce file locking that no one in the industry likes to use. But it's one example of what you can do. You can also do things like what's it called, Prometheus and Grafana, to do stats tracking. Like, for example, if you have a bigger team, lots of playtests, you can collect performance metrics or do heat maps behind the scenes, send it off to your local Grafana, and then analyze data. It might be useful.
And then put the XKCD comic when there's like two people fighting with the swords on their office chairs. And it's like, what are you
Oh,
doing?
yes.
Oh, it's compiling.
But it used to be true.
Is it
Totally used to be true.
so? What are the major improvements in this area? In terms of Unity, for example, it would be asset bundles and addressables. And as you mentioned, it means taking out of the build system the the assets that will not be changed, they will not be packaged with the entire game, but then the build game will be able to reference them later on, right?
Yeah, that's true, but I think the biggest impact Unity did is having play mode, so you don't even need to build. You
Yeah.
can play your game without building.
Yeah, that's true. That's
You
correct.
still need to compile some C#, and it used to be very quick. Now with so many packages and whatnot, reloading the .NET domain has become slower, but it's still orders of magnitude faster than making a build.
Can we dive into the details how the play mode works, how the references work? For example, in Godot, if you do that, there's a new process being opened, but the editor is not linked to the same thing. So it's like you have now two UIs, and depending on whether you click on an asset or the living thing, I have my properties and I can tweak the number. But this is not the same place as in Unity. So in Unity, you will have the inspector, and if you're in the play mode, you can modify values. Then if you exit the play mode, they will not be saved, but they are still at the same place. And I don't know which part, let's say, what's the secretive and NDA things around the things in Unity and how are they done underneath, and whether there is something secretive. But I can imagine that there is a process being run and it needs to be mapped back to the editor and the values, right?
So in Godot, as far as I understand, they run a different process, yes, because you don't build the executable at all. There's just the player executable, the Godot executable itself, and you run it with a different set of data, and it's completely data driven. So your scripts there, they're interpreted, right? And your data that needs to be built, and it's probably cached somewhere. So you just run another instance of Godot, the executable, with your data, and that's your game.
Oh,
Well, that's my understanding from, brief experiments. In Unity, everything's built in and it's in the same process. But then it's difficult to say which approach is better. Unity has very tight integration. I don't know if in Godot you can edit the scene while you're playing it.
it will not be saved, right? Like you can edit it and see the differences live. If you tweak a number, a variable, it will be applied, but it will not affect. But that's the same thing with Unity, although there are tricks around it in Unity, right? You can copy and paste the entire component and then exit the play mode and then paste component as values, and you'll be having all your changes back. Okay, nice.
So, any more details about play mode? Well, obviously, the scripting domain is reloaded, so you can have that off as an option now. So you don't even reload scripts, but that means if you have any, let's say, static variables, you need to clean them up or take care of them yourself. You have a callback which tells you that I'm entering play mode. Well, it's slightly different callback. It's something like subsystem initialized callback. I don't know why it's called that way. And if you want to improve the speed of entering play mode and avoid the .NET domain reload, what you want to do with your statics is to intercept that callback and maybe clear them to null if that's what you want to do, or maybe clear lists if they're static lists.
Okay.
I believe there's a plugin for that on GitHub, which gives you an attribute you can put on things that you want to clear, be cleared that way.
Okay. Nice. I didn't know about that. So this should really speed up all the development on top of the usual things. You learned programming a long time ago and starting from these fundamental resources, I would say. Like you started with basic Turbo Pascal and then C, and you kind of always thought about managing memory and stuff like that. And now a lot of people that start programming, they would pick up Python or JavaScript, so they are detached from this world. And what would you recommend for people? Is it useful to get into the memory management world and go low level, understand how the things work? Or is it becoming like the work and the jobs that require this become more scarce and it's not needed? How do you see this, at least in your line of work?
It's a interesting question. At the time, I did what I did because there were no real alternatives.
Okay.
You couldn't make games with anything else. And the best you had to something dynamic were scripting languages that you could embed into your project, but that's an embeddable language. It's not, it's just a small part of what you have to do. And at the time, Lua existed, I believe, and you could do that. It would garbage collect its own stuff. So nowadays, I was talking before that I'm pro traditional specialized education. Nowadays, with the advent of AI, I'm not sure anymore. I understand the current level of AI is at this weird, it can do things, but if you don't understand coding, in depth, you can believe that it does good things, but it usually doesn't. And so in 5 years of time, we probably need a new specialist who can fix wipe coded software. That's my opinion. But like seriously, if we're just talking about the job market, there's plenty of jobs where you don't need to manage memory. And even if you go to a job that does, let's say, enterprise software in C++, it will probably have enough layers on top of raw C++ that you might not even notice you're allocating memory. You can imagine that. Like, if you look at the code Unreal does, it's just it's not C++ anymore. It's just a macro language, basically.
Yeah.
So it's very difficult to say. Like where I'm from, there is not a lot of jobs compared to in C++, let's say, compared to jobs in JavaScript, just front end. And even back end, I don't think many people do back ends in C++ over here.
Okay. All right. Thank you so much for joining me, for having some time to talk to me
It
about
was
all
a
the
pleasure.
cool stuff, Unity and virtualization. Thank you.